match to the grid. I'm going to, for this, I have got a one line right here in the internal side of the solid, and I'm going to draw another line from right here about 1 mm. In order to define that, I press the space bar button and press the 1 mm and press the enter button. And now I'll join this line to the another line send, which is comes appear as a V shape by joining this. Once it is joined, you can see the V shape of the threads comes appear inside the hexagonal body. Once we are done with this V profile, I'm just going into the 3D mode in order to remove this V shape. Revolving it around the same axis. So first we are going into 3D mode. Once you are in 3D mode, I'm going to click on the home view here. So you can see the hexagonal shape is visible to all, but the surface is not is visible to us because it is inside this solid. So in order to select that surface, I'm going into the structure.
Professor, I think again there is the same doubt. People are not understanding the first element of the thread that you make, that V shape, and why are you making it and all those things. I think people are not understanding that part. You have to again, can you repeat it? Because I just got one comment.
Okay.
Yeah.
Okay. So kindly, okay, repeat the V shape that we have made. Okay. Okay. So I'm going to undo this. Here. So we are here now. So what I was, explained earlier, it was, we are going to, define a V shape onto the cylindrical surface. In order to do this, we just need to define a plane right here and going into the sketch mode by selecting this plane and selected a plane view. So here we are going to define a V shape inside the hexagonal nut. So in order to do this, first I'm selected a line. You can see I select a 1 point from the very right corner of the cylindrical surface. So I'm incline it from this point from this point to this point of the grid in between. I make it a approximation. Let us say it should be right here. Once we have drawn the inclined line in between this particular grid. So I'm disabling this command by pressing the escape button. You can see an inclined line comes appear, and I'm going to draw a line right from here to this side. For this line, the length would be 1 mm. So that means the pitch. From here, this is the width of the V shape, which is the 1 mm. I press the enter button, and you can see that the 1 mm line has been drawn, which is coincide over the cylindrical surface. And I'm going to join this line to the end of another line. So once they are joined together, I'll click the left mouse button. You can see the profile has been closed together, and the perfect V shape comes appear for the threading. So once we are done with the generating a profile for the threading, I'm going into the 3D mode by clicking right here, and I'm going to click on the home to get a perfect view. You can see we have drawn the V profile inside the hexagonal body, and it converted into the surfaces successfully. You can verify right from here. And once but you are not able to select that surface, and you cannot just it's not visible to you like this way, where the profile has been generated exactly. So you just need to zoom in. You can see there is a line. Once you are moving your mouse around this line, you can see there is a surface which has been comes visible inside the hexagonal body. So in order to select that surface, I'm going to select this surface right from this structure box. I'm going to select this, and I'm going to revolve around this axis of the cylindrical shape. So in order to revolve this, I'm going into the pull command. So once once I have selected the pull command, I just need to revolve this profile, or the surface of the V shape or the threading around this cylindrical shape. So in order to do this, I'm going to select the revolve command, and it asks for the axis first, where in for the profile that you have been already selected, in which axis you want to revolve around. So this axis I want to revolve around, which is the common for the hexagonal and the cylindrical body or the surface. I'm going to select this. Once it is selected, you can see it turned into the blue color. Once it is selected, I'm going into the revolve options right here in the options box. You can see right here there is another advanced option for the revolve command. You can see right here revolve options. In this options, there is a first option, which is the revolve helix. So in order to revolve this profile, we for the threading we need a helix, which very or we can define that helix on the 3 parameter. Once I have selected, you can see the 3 parameter comes appear. First one is the height, and the second one is the second one is the pitch. So in this case, the height for the helix would be 10 mm. Once filled the first parameter for the helix, I press the tab button. You can see the helix has been comes appear inside the body. I hope it is visible to all. Like this way, you can see. So once the helix has been comes up here, we need to define the second parameter, which is the pitch. For this case, the pitch would be let us say 1.2 mm. Make sure that pitch always should be higher than the width of the V profile. So for in this case, I have defined the width of the V profile is 1 mm. So in this case, I'm so the pitch would be the 1.2. So which is little more than the width of the profile, width of the thread profile. So once it is filled, and select the tab button. You can see there is a taper angle which is not required in this case. So I'm pressing the enter button. Once you can see, okay, so it again, okay, 10.
Sometimes you lost your audio.
Oh, are you getting my audio right now?
Now we are getting, but I think for last 1 minute we totally lost it.
Oh. So I hope you can I hope you understand the helix, how I have inserted the helix profile. That for that you got the audio.
Yeah, helix we understood, and we also understood
Okay.
that pitch of 1.2 also we understood. After that you can continue.
Okay. So you can see I'll fill the 10 mm in this case and define the pitch, and you can see it comes appear, and it failed to resolve a set of surfaces. So it's giving some error right here. Let me see. 10 mm. I'm pressing a tab button. The helix has been defined inside the profile. So I'm just going to cut it and press the enter button. So here you can see the helix that we have defined, in the uh, in the in the revolve options. Uh, so that the profile that we have generated right here and is revolved around that helix. So this way I'll show you right here. You cannot see perfect view to where if like the threading has been drawn or not. So I'm going to in select mode, and I'll show you by sectioning it right from this plane. In order to do the sectioning for the any solid, you just need to select the select the sectioning command, which is in between the sketch command and the 3D command. You can see right here there is a sectioning mode. So I'm just selecting it, and I just need to select the plane in which plane I'm just going to cut it into the half. So for this case, I'm going to select this plane. So you can see it has been, the V profile comes in here, and I'm going it, select the plane view to get a maximum, coverage. So here you can see the V profile that has been, V drawn inside the hexagonal body, and it has been revolved around this axis by defining the helix parameters inside the revolve options. So I hope this is, understandable to all, how we can, define the internal threading and the external threading on the cylindrical surfaces. I hope this is understandable all. Now we are moving to the chamfering part of the hexagonal nut, and can also define that chamfering procedure that we are going to doing right now. You can also define that chamfering profile on the on the head of the bolt, which is also again a hexagonal. So I'm turning off the sectioning mode in order to by just selecting the 3D mode. You can see we are now in the 3D mode, and the sectioning mode has been disabled. So In this case, we have, we have a plane right here, which is not required anymore. So I'm just going to disable this plane. In order to disable this plane, I'm going into the structure side, structure box. Here you can see the tick right front of the plane option. I'm just going to deselect it by clicking a left mouse button. Once it has been deselected, you can see the plane has been disabled from the design. So once it has been disabled, you can see just hexagonal body, and I'm just going to going to perform chamfering around this hexagonal body. In order to do this, we just need to uh, insert a new component right here. But why we are just preferring a chamfering for this particular case? Because it smoothens the edge of the hexagonal shape, so which profile which gives the perfect look to the hexagonal nut. And once we are just going to tighten and loosen the nut, it provides the uh, perfect contact with the the equipments that we are going to use, like keys or the
Usually lost your audio again.
Okay, are you getting my audio right now?
Yeah, now we are getting.
Okay. So so this way we have defined the chamfering, and the chamfering must be provide the strength and to smoothen the corner sharp edges of the hexagonal nut, so or the hexagonal bolt head. So that's why we are using the chamfering. So in this case, to define the chamfering, I'm going to insert a new component. So in this design, by clicking right click of the mouse button, you can see there is so many options comes up here. In this pop-up, you just see here the third option, which is the new component. It is just used to create a new component in the existing design, which create the another parameters inside the same body. So which is the separate body. You can also disable this body or enable this body at any time whenever it is required. So I'm going to inserting the new component by just clicking a left mouse button. You can see the one component one has been comes up here. For this case, I am just going to rename it, which is chamfer, and press the enter button. Now I'm going to draw a circle on this in this component by just selecting it and going into the sketch mode. And I'm going to select the base of the base plane for this of this component. So once the plane, base plane has been selected in the inside the component that we have inserted, I'm going to draw a circle. But in order to draw a circle, I'm just selecting the plane view. You can see I'm moving it into the center. So I'm going to draw a circle at the center of the hexagonal body, at the same center of the hexagonal body. So for this case, the circle diameter would be should be when it is joined at the corner of the hexagonal. So hexagonal sides. So here you can see there is a uh, 6 corners of the hexagonal shape, and I'm going to select any. You can also select any corner of the hexagonal shape, because they are symmetry or equal in each other. So I'm just going to select any of the corner. I'm selecting this corner right here, and you can see there is a right below the dimension cursor. You can see there is a green point comes up here, which shows that the circle has been perfectly coincide to the edge. Once it comes up here, I press the enter button. Once it has been pressed the enter button, the mouse got released, and I'm going to convert it into the 3D. In order to do this, I'm going to going into the 3D mode. Once I'm in 3D mode, you can see the drawn sketch has been converted into the surfaces, and I'm going to convert it into the 3D by using the pull command, and going to select this surface. You see the yellow arrows are comes up here, and dragging it into the positive direction by clicking a left mouse button and press the space bar, and fill the required dimension, which is the 10 mm in this case, because we already defined the 10 mm height for the hexagonal body, so that the height of the circle should be 10 mm in height. And once the 10 mm is filled, I press the enter button. You can see this chamfer component cover the whole hexagonal body. Once it has been successfully covered, we just need to provide the chamfering around the cylindrical surface. So for this case, you should make sure you are in the pull or the 3D mode. Once you are in the in the pull command selected, you just need to select the edge where you want to apply the chamfering. So I'm just going to select it by clicking a left mouse button. Once it is selected, you can see it is turned into the yellow color, and I'm going to again select the another sharp edge of the cylindrical surface, but make sure you are pressing the control button in order to select the both of the sharp edges. So this way you can select the sharp edges of the cylindrical surface. So once they are selected, you can see there are the dress-up features comes up here. And the very first one is around which we have already covered in the previous sessions. So the second option is the chamfering. So I'm selected this chamfer option, and you can see there is a yellow cursor around the edges comes up here, and I'm going to select it by clicking a left mouse button and dragging it into the into the downward direction. I'm dragging downward till when this this circle has been tangent to the hexagonal body. So here you can see the chamfering of the circle. The circle has been generated. You can see even while we are providing a chamfering to the cylindrical surface, and that circle has been comes appear as a tangent to the hexagonal body. So once it is tangent to the body, I'll press a spacebar button and rounding off the dimension, which is a 1.5. So I press the enter button. You can see the chamfering has been applied to the cylindrical body. So I'm zooming it. You can see the you can see the chamfering has been applied, and And now we are going to remove the material which is not required or is not required for the nut. So in order to do this, we can use the combine command. Combine command, we earlier used to combine the two components, those who are intersected each other, or where the two faces of the component has been joined together. So for this case, we have already used the combine command. But in combine command, there is a first option, which is the cutter option. Let me select the combine command first. You can see there is two options that are disabled at this time, because I have not selected any one of the components from the design. So in order to enable the cutter option, that cutter option uh, cut the overall the all bodies where the you can see there are the lines of this component, and of the second component, which is the hexagonal nut. And from all the intersecting lines or the surfaces of the one component to the other component will be intersected. So in order to apply the combine command using a cutter feature, I'm going to select the first component of the design, which is the solid. It is also the this solid, which is the sub part of the chamfering. So I'm going to select this, and I'm going to select the cutter command, and what part should be cutted from this cylindrical surface. So I'm going to select this solid. You can see I'm just going to enlarge it. So you can see the different solid has been comes appear. You can see if I'm going to select this, but make sure I'm disabling the I'm going to disabling the combine command first. I'm going to select the select command. So now I can easily select any of the solid which has been intersected from the body. So you can see the all from where the it is intersected with the first solid. Uh, it has been intersected from the all sides. So in this case, what part we are need, you just to keep enable it, and the rest of the part that are not required in the in this design, you just have to disable it. So in this typical case, the very first component, which is the the internal part of the hexagonal nut, is not required, because there should be nut nut threading, and the bolt has to be placed inside the nut. So I'm just going to disable this solid first. Once I have disabled, you can see it gone from the the environment, and you can see the perfect threading. You can see right here. And again, I'm just going to disable the all sharp edges, or this component of the solid. So if I disable the solid, you can see uh, the top side of the the top side of the sharp edges has been disabled. There is yes. Actually, there is a little problem right here. Actually, the diameter of the chamfering has been is a little less, so that's why it it did not cut this portion. So right here, I'm just going to undo this command right here. I'm just going to increase the diameter, which is a little bit 1.55, let us say. So I'm applying the command, this command, and so we are back. Yeah, sorry. Should be 1.55. So we are back. So in this typical case, we are not required this part, and this solid, and this solid. We require this solid, I guess. Yes, this solid we require, and we do not require this these components. And this component. So here you can see only one solid which is required to provide the perfect chamfering around the hexagonal body, which is a nut. So this way we can provide the chamfering around the one solid by introducing another component around the same component. So after that, once you have successfully inserted the this component, you just have to apply the combine command. Once you have successfully applied the combined command, you just have to disable the unrequired component from the structure options or the structure section. So I hope this is understandable, that how we
I think this is a very good explanation and very detailed. You have been very patient in explaining all the steps. So I'm sure people must have understood. Now, if still there are any questions, we can take those questions offline. Let people again send you a mail like this and yesterday, and then you can answer those queries one on one basis. But I'm sure now there will not be any more questions because you have really explained it very nicely. I think we can go ahead for the last design that is there for the workshop, because we already are 1 hour into the workshop and we only have 1 hour left. So I think we can go ahead with the new design which we have kept for today.
Okay. So once the design has been done, you can rename it. So now we are going to design a new design, which is a pen. The most common, the equipment that we are, using to write our.
Sir, can you first show the picture of the design that you have already made? I think that will make it more clear what they are going to do.
Let me see in the directory first, sir. Okay, yes, I do have. Okay.
Yeah, maybe you can show that. Oh.
I'm going to, here is the pen body. So you can see this is a pen body which that I have been designed right here, and the second one that component which has been I have been disabled, which is the which is just to place right here in order to fix the refill of the pen, and where you are just going to picking just placing the pen right in the hand and used to write, which is so
that is understandable.
So I hope you are clearly visible that the pen that I have been made again using the hexagonal shape. So we are going to design this component in from very start point in the environment. So I'm just going to close this line. Here, first we are going to design a pen body. So I'm going to rename it pen body, or you can rename it in the property section right from here. Once the environment comes up here with the selection of the sketch command, and I'm going to select the plane view. Once it is perpendicular to the screen. So I hope you are getting my audio.
Yes, we are getting.
Okay. So we are going to draw the hexagonal shape right here at the very center of the coordinate system. Again, the 3 parameter comes up here for, in this typical case, the diameter of the pen it should be should keep the very perfect. It should keep the accurate, so that can be easily to handle in the hand. So in this case I keep the standard size of the pen. So in this case, the circle of the hexagonal, which is going to tangent to the all sides of the hexagonal shape, and fill the diameter for that is the 8 mm. Once it has been filled, I press the enter button 8, enter button. So once it is converted into the you can see it is perfectly closed, and all the parameter has been filled, and I'm going to select the pull command. You can see that the whole sketch is converted into the surfaces successfully. Once it has been converted, I'm just dragging right to the corner. So here I'm just going to convert it into the 3D by just selecting it by clicking a left mouse button and dragging it into the positive direction. So the height for this pen should be 100 mm, let us say, and that is pretty fine for the for designing a pen. I'm pressing the enter button right now. You can see the hexagonal body has been, comes up here in the environment, and to make it a hollow from the inside, I'll apply the shell command. So I hope the shell command is clear to you all. If it is not clear to you, you can learn right from here. For this, you just go into the insert section, from where you can see the shell command right here. So once I have selected it, it asks for the the surface which has to be removed from the solid. So for this case, this plane should be removed, and it asking for the wall thickness, which should be provided around the uh, which should be provided around the uh, walls of the solid. So in this case, let us say I am filling 1.5 mm and press the enter button. And I'm going to disable this command, pressing the escape button. So here you can see the shell command has been applied to the pen. So this part of the pen has been successfully built with the shell command. Now I'm just going to define this area by creating by selecting this plane in order to do a sketch right here, because I do not want any hexagonal shape right at the end of the pen body. So here I am going to select this plane, and by clicking the left mouse button. So I'm going into the sketch mode. So once I am in the sketch mode, I'm going to select the plane mode. Once it is selected, I'm zooming it. So here, I do not want any hexagonal shape right at the very bottom at the body. So I'm going to draw a circle right at the center of the hexagonal body. So I'm just coincide this circle to the sharp edges of the hexagonal body, or the hexagonal sketch, inside sketch. So once it is coincide together, they show green point right at the edge, and I'm press the enter button in order to freeze it, and I'm going back to the 3D mode by selecting the 3D mode command, and I'm removing the this traces from the from the solid. So in order to do this, I'm just going to press the control bar and select all the sharp edges and dragging it into the negative direction. But make sure you are also selected this component. So I'm dragging it. Press the, let us say it should be 12 mm. Let me select again, once again. Select all the components and dragging it to the negative direction. Let us say the height would be 12 mm. So here you can see the curvature has been applied, and I'm just going to disable this surface. So here you can see the round shape has been applied to this internal hexagonal shape by just inserting a circle inside the hexagonal body. So once we are done with this, we just need to verify the diameter of the circle by using the the vernier caliper sign right here. You can see in the investigation mode. From right here, you can see you can verify the perimeter and the area and the cylindrical diameter. So in this case, the diameter, which is around 5.77 mm, so which is pretty fine. So if you want to increase the diameter more, you can also increase the diameter. Um, so we are now going to insert the new component right here in the body, and or right here. So in this case, I'm just clicking a right click on the structure menu and click click on a new component. So once I have clicked the left click, you can see the new component comes appear, and I'm rename it body. So in order to make a solid inside this component. I'm going to select it. Once it is selected, I'm going into the sketch mode in order to draw any sketch in this component. For this case, I'm going to select this plane. Let me rotate it first. In this plane. So in this case, we are going to draw a sketch in this plane. This plane. Okay. So once it is selected, I'm going into the plane view. I'm zooming it.
So we are getting problem in the audio again. Maybe
It shows that.
So
I hope you are getting my audio right now.
We are getting, but it was little shaky. Can you go back to one step where you are adding the new component? After that, what you said.
Okay. Okay. So I'm doing it. So we were right here, and in order to draw the lower part of the pen, we are going to into the structure box, and where you can see the pen body, and clicking a right click of the mouse button, and you can see the various options comes up here, and where you can see the third option, which is the new component. In order to generate the second part of the pen, just click the left mouse button in order to add the new component. Once the new component has been added, I rename it as let us say body. So this way we can we are able to add the new instance in the design or the component. So once I have selected it, in order to draw the sketch inside the inside the component, I just need to select the sketch mode, and I need to select the plane where we are going to draw the sketch inside the component. So once the plane has been selected by clicking the left mouse button, and I'm going to select the plane view. Once it is selected, I'm zooming it. Sir, you are getting my audio right now, or it's a little shaky?
No, we are getting. It's fine. You can please.
Okay, fine. So I'm going to draw a circle right here first at the same center. So I'm going to coincide it, or we can make a little tolerance right here, which is, let us say, make it a 5.2 mm, and press the enter button. So once the circle has been drawn, you can see it appears right here, and I'm going to draw another circle at the same center, and give some the diameter to the circle. Let us say it should be 4 mm. So once insert the two circle, you just need to go into the you can spin it, and you can see the two circle has been successfully inserted in on the sketch plane, which is the sub part of the lower body. You can also verify right from the structure box. So these curves. These curves, those are generated here, are the part of the lower body. So now we are going to convert it into the 3D. In order to do this, we go to we need to go into the 3D mode. Once you are in the 3D, you can see the surfaces. the all curvatures has been successfully converted into the surfaces. And I'm going to select the pull command. I just need to, extrude this part only, or the pull this part only, because it is required in order to, provide some, to fit it in to inside the, inside this cylindrical curvature, or this surface of the, hexagonal body. So we are just dragging it into the, opposite side, and let us say it should be 10 mm. And you can see the cylindrical surface has been generated, but this surface that we do not require. So I'm just going to disable the surface by, clicking a left mouse button. You see the surface has been disabled, the inside surface. So in order to, see this perfectly built generated solid inside this component, you just I'm just going to, zoom out and a little bit spinning around. And I'm just going to disable this hexagonal body in order to see this build cylindrical surface right here. So you can also disable this component from right here by just clicking a left mouse button. You can see the component has been disabled. The cylindrical surface that has been generated, you can see perfectly. So once you have been verified with the component which you have been drawn, you can also enable the required component. So the part of the lower body which is going to be insert in the upper pen body. So the lower section of the body has been which should be inclined in order to support the refill, or support the nib of the refill. So in order to generate that part, we just need to go into the sketch mode again, but make sure likewise I've already cleared that we just need a plane in order to sketch with this cylindrical surface. So I'm just going to insert a new plane by clicking a left mouse button, and where we are just going to insert this plane right at the center of the hexagonal body or the cylindrical surface. So in order to do this, we just need to select the axis of the common axis of these two components by clicking a left mouse button. Once it has been selected, you can see the plane comes appear right here, and escape button. Dragging it downwards. So we are going to draw a sketch on this plane. In order to do this, we are going into the sketch mode and select it. Once it is selected, you can see the sectioning also, and the sketch mode turned on, and I'm going into the plane view. I'm making it to the center a little bit. So here we are going to draw the slant lines which which is again revolved around this axis. So so for this case, I'm zooming it a little bit, and I'm selecting a line right here, and and selecting selecting a point right from the this point, midpoint of the the grid. Once I have clicked the left mouse button, you can see the line comes up here, and I'm zooming out a little bit and dragging it into the upside. So the length of the inclined line should be let us say let's first define the angle first. Let us say it should be around oh, trying it upside. So let us say it should be 80 to 85 mm. So by pressing a tab button, you are going to shift into the the angle parameter. So here you can fill the required angle, which is let us say 85 degree, and press the tab button. And now you are into that in the dimension of the length of the line. So where we are going to fill the length of this line, let us say it should be 40 mm, and press the enter button. And I'm disabling this command by pressing a escape button right here. Once it is press the escape button, the command has been disabled. And I'm zooming out a little bit and dragging it into the upside. So you can see this way we can draw the inclined lines. So I'm going to again select the line command and make some thickness right here. And let us say it should be 0.1 mm or 0.8 should be also fine, but I keep it 1 mm to for make it a perfect solid. 1 mm, press the enter, and zooming out and dragging it a little bit downside. And I'm going to join the end of this line with this cylindrical section of the solid here. Once it is coincide, you can see the green icon comes up here, and I'm clicking a left mouse button, and it is joined together. And again the line comes up here, and I'm going to join this line to this line, the very first line that has been drawn from the midpoint of the grid. And I'm going to close this sketch by just clicking a left mouse button, and you can see the profile successfully has been closed together. Now you can see the cross section of the the lower part of the pen has been generated successfully. Once the cross section of the lower body has been generated, we are going to we are going to shift into the pull command or into the 3D mode. You can see the surface is perfectly closed and it is converted into the surface. The lines are perfectly closed, and what we are missing, no, perfect. So or you can see right here, or we can extend this line to this point also, in order to moving again into the sketch mode. Like I'm going to again into the sketch mode, and let us say you can see right here, but make sure you have select the select command, or we can move it to move it to this side. Yes, right here. So you can also customize your sketch by by using a select command and dragging it into this direction, or either in this direction. So I'm doing this I was just want to clear that that how you can move the sketch around the sketch plane. So if you have any error around in the profile or in the sketch, you can also drag or drag inside out or drag in the upside down. So I'm undoing it. So we are back in the pull in the 3D mode and the pull command. So here you can see the surfaces, and I'm going to revolve this surface around this axis by selecting a revolve command. But make sure you have in the pull command because it is only visible when you have selected the pull command. Once it is selected, you just you need to select the axis in a way axis, and once it is selected, it is turned into the uh, blue color, and it is asking for the profile which you are going to revolve around this axis. So I click the left mouse button and press the space bar. You can see that the checkbox right here, and it asking for the angle for let us say I'm revolving it about 360, and press the enter button, and you can see that profile, that the cross section of the lower part has been revolved around this axis. Or let us say I'm going to repeat this again. I'm undoing it. Let's make it 180 degree first. I'm going to click right here and press the space bar, and I'm going to fill the 180 and press the enter. So now you can see the half of the profile has been revolved around this axis. So this way you can also uh, create the profiles around the axis. Likewise, we previously done the threading inside the body. But in that case, the profile that we are revolving around the cylindrical surface has been removed from the solid. But in this case, the profile has been inserted. So I'm going to undo it, going to make it into the 360 degree. So here you can see home button. So you can see this way you can generate the lower part of the pen, and you can seeing it by disabling this component. You can see the component has been successfully generated where the riffle has been placed. In order to provide the perfect provide the corners to avoid the sharp corners, you can provide the rounding around command, but make sure you are into the pull command and select the sharp edges and dragging it into the downward side, and let us say it should be 0.8. Press the enter button. See, the curvature has been rounded off, and you can also apply to this edge or this edge simultaneous by pressing a control button and dragging it. Let us say it should be 3 mm. 0.3 mm, sorry, 0.3 mm. Fail to build rounds. Right, 0.3 mm. So you can see this way you can also apply the round corners to the to the sharp edges. So in order to save this file, so let us say I'm going to save this component. For only this component I want to save. We just disable all components, which you can see already disabled right here, and going into the file section and go into the save as, and click on the save as option, and I'm going to the desktop and click on the raw file, which is the RS doc, and let us say it is lower body. Now I'm going to click on the save button. The file will be saved. So the lower body is saved right now. So again, I'm going to do for the upper body. In order to do this, I'm going to disable these components, the lower component, and going to enable the upper component once it comes up here, and dragging a little bit into the center, and to make it active first. I'm going to right click on this the lower body, where it has been written a lower body. I'm going to click a right click and make the component active. So once the component has been active, you can see it will be turned into the green color. So here you can see this component is active right now, and we are going to save this component. We are going to again into the file and the save as, and once you have renamed your component, and click on the save button. So this way you can save the components. If you want to verify the component has been saved or not, you can check into the directory, or let me insert the lower component right into the environment. I'm going to the file and click on the open, and here you can see the lower body. And once I have selected this and click on the open, and you can see the component comes up here. So successfully the two component has been generated generated inside the in the software, by taking the reference of the first component. So you can see this is the pen body, and this one is the lower body. So this way we can save the components, and you can also convert these components into the STL files in order to print these components. So I hope this is understandable to all, that how we can insert the components inside the structure, and how we can apply the commands, and how we can save those components in order to print in the 3D printing machine. So I hope this is clear to all, and for this is we are almost done with this design. So I request Sagar sir. So the design that has been built in the component in the software has been successfully completed. I would suggest you to, or ask you to provide your suggestions.
Yeah, I think it was nicely done. If there are any questions, we can take questions from the participants. Okay. I think there were a lot of new elements which were not covered in the earlier designs, which has been covered in this particular design. Yes. So that way,
I hope this is understandable. If it is not clear to any one of the participants, you can directly.
So we are asking people if you have any feedback or comment or any question, please ask. You can write in the chat box.
Someone is asking how we can easily convert a 2D design to a 3D one. Simply just you just go into the sketch mode. You just need to draw the particular sketch in 2D that you want to convert into the 3D one, And but make sure once you are done with the 2D sketch, you are going into the 3D mode, and so you can also convert into the 3D.
Any other question? Anybody has any question? Okay, then I think we can wrap up. We will share the video of this particular session with the participants, and if there are any questions, people can reply back. Now, Chanpi sir, I would request you to please open the 5th design, which we are giving as an exercise, and I will request Ashwarika to please explain what we expect the participants to do in that. And then probably on August 10th, when we are meeting again with all the participants, we can request the participants to show their design which they have carried out, and if there are any questions, we can address those questions on August 10th, and then probably we can show how we are carrying out that particular design. So can you open that design, the 5th one, the nameplate? It's a very simple design, so all the participants can easily do it. So if you can open it, maybe Ashwarika can explain what this design is and what are the commands that we expect them to use.
Okay, so let me.
You don't have it in your.
Let me see in the directory.
Okay. If it's not in the directory, maybe you can open the JPG image. So meanwhile, if there are any questions, people can ask. Sir, are you opening that?
Yes, sir.
Okay.
So,
yeah. We can zoom it a little. Yeah. So, Ashwarika, can you please explain what we expect them to do?
A very good afternoon to all. So we have this design with us, and now we have completed successfully completed 4 days of 3D printing and 3D designing workshop, and I hope and believe that it was a good exposure to you all, and now you might be very much aware of the tool and the commands, because there were many commands which we have used regularly. So you are now in touch with the tool. So this is design, the last design of the workshop, which we are giving you as an assignment. We have chosen particularly this design because this is a quite a simple design, and the commands used in this design are explained earlier in 4 designs. So we are expecting from you to try it from your side and assume the way you want to design it. Then on the 10th August, I will be designing the same design for you, and then we can compare that. As I earlier also told you, that for a single design we can use different and various approaches. So we will be having a comparison also on different analysis, and so basically the major commands used for this design would be simply the sketch commands, that is circle, rectangle, line, and then tangent arc. That will be a new for you, but I want that you should at least try it. If not possible, then I will surely explain you in detail.
So where have we used tangent arc?
Yes, you can see the curve. There is a circular body upside, and at the lower side you can see a rectangular body, and these two bodies are connected through a tangent arc. As you can see the bulging curve inside. Here we will use the command tangent arc. So I just want you to try this, and if not, then surely we will do it on 10th August. And then there is next commands are in that are simple commands. We will use full command that we have used various, and that is the most common command which is being used throughout the entire workshop. And in future also, if you will go for designing, that is the most basic command which you will be needing, because that commands converts a 2D sketch into 3D sketch. And next you can see we have engraved Chitkara University on the, as the name of the design is nameplate. So we have engraved Chitkara University. So I would suggest you all that it's a nameplate. So just write your name so that we can see everybody's name on nameplate, and even you can show to others that yes, I have designed my nameplate by attending a 5 days workshop. So it will be something an outcome of this workshop. So I will suggest you, rather it's just your option, whatever you want to do, but it will be beautiful if you will write and engrave your name. This is done by using text generation, which is earlier explained in one or two designs. Now you have a chance to again practice text generation, as some were having the error also and problem in using that command. So it will be a practice for you, and again, if you will not be able to do that, then we will surely do it on 10th August. So this was the basic, and now you can see 3 circles which are used to place the nameplate on the wall. So they are just simple circles, and you need to pull out and use the pocket command. So this is the basic and a very simple design which is being given to you as an assignment. So I hope you all will do well, and we will get some good nameplates.
Yeah, and one more thing I want to re-emphasize, that we will be happy to print one design each for each of the participants, and we can definitely ship it to you through courier. So, we will definitely charge you, but the charge will be very nominal based on the operational cost of our 3D printing and the material that we will let you know in advance. So let us say if somebody of some of you are interested in getting your designs 3D printed, you can send your design. We can tell you the cost estimation, and if you are happy with that, you can pay us, and we will be able to print it to you. We will be able to print it and send it to you. So I think that you can use this opportunity, and this opportunity is there till August end. We may not want to prolong it for too long. So by August end, if you are ready with some design or something, we'll be happy to print it. We'll be also happy to optimize your designs, and during the optimization, we can have a video call with you so that you can also learn some of the optimization technique both in the Cura software and Design Spark Mechanical. So that will be a good closure for you for the workshop. So with this, Chandri sir, do you want to add anything, or shall I close?
So this is done pretty explained by you. So there is nothing from my side.
Yeah, so today we are wrapping up little early, so that way you have a early break. So have a nice day and have a nice weekend. Try this Design Spark Mechanical thing, and please come back to us on August 10 with your designs. Thank you very much. If you have any feedback, you can always write a mail to us. So that will be great. Thank you very much. So I'm just signing off.
Okay, thank you, sir.
Thank you.